Welcome everybody. So today we're going to do our last video for atomic structure, and it's going to talk about the current things you need to know for Regents chemistry, like how many protons, neutrons, electrons there are in an atom, how to go about figuring out the mass of each one, the mass of the atom, what an ion is, and so forth. So, the first thing I just want to summarize for you is the wave mechanical model. That's what we've been studying all along here. This is where the electrons are arranged in orbitals. And so we have the electrons, they're in orbitals, regions of space where you're most likely to find an electron. What I want to talk to you mostly about, though, for this video is the subatomic particles. So this is my representative element, chlorine, and in chlorine I have two parts here. I have something called the atomic number and something called the mass number. Now, this could be written like this as well: chlorine 37 and 17. What these numbers represent are the number of particles that you see below in the box here. So, for example, we have protons. So protons, they have a mass of 1 AMU. The neutrons, they have a mass of 1 AMU. And the electrons, they have a mass of 1/1836 of an AMU. The charge, the protons have a charge of +1. The neutrons, they have a charge of 0, and the electrons have a charge of -1. Now, you could also look at the mass of each one of these particles in grams. And so if I were to do that, if I were to figure out, well, what is the mass of a proton in grams, I would get 1.66 times 10 to the negative 24 grams. You can see why we would use an AMU compared to grams. And then if we have a neutron, that would be the same 1.66 times 10 to the negative 24th. And if we have an electron, we take this number and we divide it by 1836, and we get 9.11 times 10 to the negative 28 grams. Now, how do we determine this? What's the skill that we need to determine for an atom how many, of each particle? So let's look at our chlorine here. The protons, this is equal to the atomic number. So for example, if we have chlorine and we see the atomic number is 17, then we know that this would have 17 protons. The neutrons, we take the mass number minus the atomic number. So in this case, for chlorine, we would have 37 minus 17, and we would have 20. For the electrons, if it is an atom, the electrons are equal to the number of protons. So since I have 17 protons, I would have 17 electrons. So this is how I look at, my number of protons, neutrons, electrons. Something else I want to bring up here are the symbols for each one. So the symbol for a proton, sometimes they'll use P and they'll do 1 and 1. Sometimes they'll even use a hydrogen as the symbol and they'll do 1 and 1. For a neutron, they'll have 1, 0, and N. And for electrons, they'll have 0, -1, and E. So this is how I have the protons, neutrons, and electrons. And we'll practice a lot of this, how to assign them. But you have to know that it is the mass number minus the atomic number to find the neutrons. It is the atomic number that are the protons. And in an atom, the protons and the electrons are equal to each other. So the electrons are just equal to the number of protons. But there comes a situation where you can actually lose or gain subatomic particles. Well, what particles can you lose? You can lose electrons. And you can also gain electrons. So with that in mind, if you have electrons or an atom where you lose electrons, you will become what's known as a cation, not a cation. A cation is a positive ion. You lost something negative, electrons. Therefore, you became more positive. Or you could gain electrons, and you become an anion, which is a negative ion. You gain something negative, you become negative. You lose something negative, you become positive. Remind me in class to tell you the sodium joke. Now, I can remember this cation, positive, anion, N for negative. Positive, negative. So what does this look like exactly? How do we show an ion? Well, let's say, for example, we had something like potassium. We show the ion by showing the charge. This charge means that you are an ion. So now, I look on the periodic table. So I use the periodic table, and I look up potassium, and I see that on the periodic table, potassium has 19 protons. Those protons are positive. Normally, if it was an atom of potassium, it would have 19 electrons. But now we have a situation where we have an ion of potassium. It has a +1 charge. So how can I get a +1 charge? It has 19 protons. Overall, it's +1. Well, let's do a little math here. If I have 19 positives and I want a total of +1, how many negatives would I need? Hopefully you said 18 negatives. And that's right. K+, it lost an electron. It became a cation, which is a positive ion. And so this actually has 19 protons and 18 electrons. Now, it doesn't always have to just be plus. It could be +1, +2, +3. It could also be negative. Let's take something like O2 negative. So now I look on the periodic table. How many protons does O have? The atomic number is 8. It has 8 protons. Overall, though, the charge is -2. Protons are positive, so it has 8 pluses. How many negatives does it need to have? To make -2, it would need 10. So it has 8 protons, it has 10 electrons. Now, some important things about the atom, okay? What determines the mass of an atom? So you should know that this is the protons plus the neutrons. The units for the mass of an atom, for now we're going to use something called AMU. Later on, we'll use grams per mole. All of these atomic mass units are based on what's known as a relative scale. This relative scale is actually based on 1/12 the mass of a carbon 12 atom. Now carbon-12 is a specific isotope of carbon, and I'll tell you what an isotope is in a minute, but it's based on 1/12 the mass of a carbon-12 atom. Now how do I measure the mass of an atom? Well, what you're going to see is that later on, you're going to see that the units that I'm going to use are grams per mole. And we haven't really talked about what a mole is, but a mole is a whole lot of atoms, and that's really what it is. So, this is my these are my things I need to know about an atom, and this is how you find the charge and the number of protons and electrons. Now, I just want to talk about something that's important about these electron configurations. So go back to this slide, number 39. And that is drawing the electron configurations for these. And so if I were to have, for example, oxygen, O2 negative, I would have 1s2, 2s2, 2p, and normally it would be 2p4 because it would be 8 electrons. But now it's going to be 2p6. This is 10 electrons. Okay, so the last thing I want to talk to you about are isotopes. And if you look on the periodic table, there's a little nuance there that you have to be careful of. Let's take, for example, carbon. Carbon, if we look at the numbers on the periodic table, we have the following numbers. We have the atomic number, and this number is a little bit different than what I described. If you looked at before, I was showing you whole numbers, 6 and 12, 6 and 13. I did this with chlorine, 37. That's because they represent slightly different things. This number with the decimal is called the atomic mass. These whole numbers here are called mass numbers. It may seem like, well, what's the difference? But there is a difference between them. The mass number, these diagrams here, these symbols that I drew, this is for specific isotopes of carbon or of any element. I'm just going to put of an element. What an isotope is the same element with a different number of neutrons. This will lead to different masses. For example, if we look at carbon-12, this would have 6 protons and 6 neutrons, whereas carbon-13 would have 6 protons and 7 neutrons. Because of that, they have a different number of neutrons and a different mass number. It makes them isotopes. Now, what is this 12.011? This is atomic mass. What this atomic mass is, it is a weighted average of all the naturally occurring isotopes. So mass number is for specific isotopes. Atomic mass that you find on the periodic table, that is for the whole weighted average of all of the naturally occurring isotopes. So how do we find that? How do we determine that average atomic mass of an atom? And so here I give you, some element Y. I don't think it's supposed to be yttrium. It's just some random element. And it contains 5% Y14, 15% Y16, 80% Y18. What's the atomic mass? So they're asking me to find the weighted average. A straight average, you add up 14, 15, 16, or 14, 16, 18, excuse me. You divide it by 3, you get a straight average. This is a weighted average. I take the percent of each one and I multiply it by the mass. I take the percent of each one and I multiply it by the mass. And I take the percent of the last one and I multiply it by the mass. I then add up my answers and I then divide by the total of 100%. Now when I do this, and you can try this, at home, 5 times 14 should be 70. So I get 70. 15 times 16 is 240. 80 times 18 is 1,440. I add them all together and I get 1750. Divided by 100, I get 17.5. So my question to you is, does this make sense? This is my average atomic mass. This would be an AMU. Does this make sense? That's my question, and I'm going to pose that to you on the actual, sheet. So this is how you find an average atomic mass. I like to say I get mad, and that means I multiply. So for this, if we highlighted, I multiplied, then I added, and then I divided by 100. Let's not do blue again, that's not going to work. Then I divided by 100. So I multiply, I add, and I divide. So I leave you with this question here at the end here. Which elements are isotopes and why? So come tomorrow to class with that answered. That's our whole unit. Thank you for watching all these videos. Hopefully they were helpful for you. We've done a lot of in-class stuff too that goes along with this. But between the two, you should hopefully be able to, really get a good idea for this chapter. All right.